Okay, so in homework 2C, the one of them that's due tomorrow, you've got number 15. So I just wanted to go over that. So that was it was y equals, forgot that part, 1 plus cosine of 2t all to the fourth power. So again, just to emphasize, we could rewrite this as 1 plus cosine of 2t all to the negative 4 power, and then take the derivative. So to take the derivative, you'd bring the negative 4 down, and you'd subtract 1 from the exponent, and you'd carry that inside along. So 1 plus cosine of 2t. Okay, so now we go in and take the derivative of the inside. The derivative of 1 is 0. The derivative of cosine is negative sine, and I carry that angle along. And then I multiply by the derivative of that angle that I carried along, and that's 2. Okay, so then in, let's see, for 2C, you saw that you've got these, well, you watch the lecture, so you need to finish listening to section 3. I think there was this problem at the end of half-life and a percentage left, and you need to finish the lecture notes in section 4 and the section 5. I know I'm challenging you a lot. We'll pause tomorrow. We will not go over new material. We'll just practice this. Okay, so on number 1, this was y equal, so it was hyperbolic cosecant to the fourth of g of x minus 3 to the pi over x. Wow, that's pretty ugly. So let's invest some time rewriting this thing. So this 4 here means the whole thing is to the fourth power. So I carry along this hyperbolic cosecant of g of x. Okay, so one of the most challenging things is to remember to put the h. So if there's an h here, you have to put the h here. And then as I move forward to this next one, I'm going to say minus 3. And let's take time to rewrite this pi over x. So this is like saying pi times x to the negative 1. Remember, we talked about 1 over x as x to the negative 1. And this just has the number pi times it. So I'm just going to write that up here. Pi x to the negative 1. Now let's go do the derivative. All right, so if I want to take the derivative here, I'm going to bring the 4 down, and then I'm going to subtract 1 from the exponent. And then I take the derivative of the hyperbolic cosecant, and it's just like the derivative of cosecant, so except it's got the h's, right? So cosecant, cotangent with the h, and you carry the g of x along. And now it's our job to take the derivative of the one angle, so that's g prime of x. Now we move on to this next term. So you know, I'm just going to write it down here, the derivative of a to the g of x is a to the g of x, ln of a, and then the derivative of the g, right? Okay, so here's going to carry this negative sign along. Derivative of this gives it itself, right? Pi x to the negative 1, ln of 3. Let me erase here so I can make some room. And now I'm going to take the derivative of this pi x to the negative 1. So I carry the pi, I bring the negative 1 down, and I subtract 1 from the exponent, right? So let me just write it up here, pi x to the negative 1. So if that's like the separate little y, the y prime would be negative pi x to the negative 2, and that's what I have here. Wow, that's ugly, right? So this thing, if I wanted to, I don't think I simplified my answers too much, but I see a negative and a negative makes a positive, right? And then 3, and you could rewrite this as pi over x, ln of 3, and this pi can just hang out here, and I could put this x squared in the denominator, and then this is just as it is, right? I wouldn't do anything with this one. So y prime, I guess the cube, the negative 1 cubed give me a negative, right? So I have a negative 4, and then I'd still have this trig function, big ugly thing, right? G of x, cotangent, h, g of x, all cubed. Big ugly answer. All right, so then the one other that I wanted to do, oops, I ran out of paper here. So let me erase up here. And I wanted to do number 17. So this was a little challenging because, again, I'm contrasting when you have the whole trig function to a number, and as opposed to when you have cosh t e to the t. So there's no outside power. So when I'm taking the derivative of this, I start with the derivative of the cosh. So y prime would be the sinh, right? I'd carry the angle along, and this angle has, do you see it? You see it? It's product rule. So to take the derivative of this, I'd have first t, derivative of e to the t, which is e to the t, plus second e to the t times the derivative of t, which is 1. And that would be the answer. Hopefully this helps.